The lesson that we're going to focus on today is 12.2 in your textbook, and this is graphing, this is systems of linear inequalities. Systems just means that we're going to have multiple equations, inequalities. And it says that this section is basically the same as 7.3, which was graphing inequalities. And the only difference is that there's going to be two lines graphed on the same coordinate plane. We still use a solid or a dashed line and shade above or below the lines, but the final answer is going to be where the overlapped shaded region is, if there is any. All right, so let's start off with slope-intercept form. So remember, slope-intercept form is y equals mx plus b. Okay, refer back to your notes from last Monday on how to graph these. So this is my y-intercept at -2, and my slope is -1/3. So I'm going to go down 1 and over 3. And I'm just going to go ahead and keep doing that and reversing it. You don't necessarily have to do this many, it just makes the line look a little bit nicer. Okay, and then the next thing I want to pay attention to is my inequality. So that tells me it's going to be a solid line. And then the other thing that it tells me is because it's greater than, that I need to shade above. Okay, so I'm going to use a solid line. And I'm going to just really lightly shade above. Okay, so don't go really crazy with this. So this is the region that is shaded. Now I'm going to look at the second line. And I'm going to plot my y-intercept at -7, and then I'm going to do a slope of -1/3 again. So that means I'm going to go down 1 and over 1, 2, 3. Down 1 over 1, 2, 3, and I'm going to reverse it. Okay. This inequality also is going to be a solid line because it's the equal to. And again, because it's a greater than, that means I need to shade above. So I'm going to draw my solid line. Now for this one, I'm going to shade above. All right, and so remember that my final answer is where the two shaded regions overlap. So I'm going to go back in and kind of darken in. This is where they both overlap. So this is the only final solution set. If you had a pencil, you could erase this since they don't overlap, or you can just really darken in the region that they do overlap. All right, let's try another one. All right, so again, it's in slope-intercept form. Let's plot this on our y-axis at 1, and then we have a slope of -5/7. So I'm going to go down 5 and then right 7. Okay, I could also reverse it. I could go up 1, 2, 3, 4, 5, and back 1, 2, 3, 4, 5, 6, 7. Looking at my inequality, it's a solid line and it's a greater than. So solid line because of the equal to, and it's a greater than, so I'm going to shade above. Okay, so I'm going to draw my line, and then I'm going to lightly shade above. Okay, so that's the side that would be shaded. Looking at my next inequality, I'm going to graph my y-intercept at 8, and then I'm going to do a slope of 2/7. So I'm going to rise 2, and I'm going to run 7. 1, 2, 3, 4, 5, 6, 7. Or I could reverse that, and I could go down 1, 2, back 1, 2, 3, 4, 5, 6, 7. I'm going to look at the inequality. It's a greater than, so that tells me two things. One, it tells me to use a dotted line or dashed. And then because it's a greater than, I'm going to shade above as well. So I'm going to use a dashed line, and I'm going to shade above it. Okay, and again, my final answer is where the two regions overlap. So if I look, they're overlapping in this little region right here. So I'm going to darken that in. That's the final solution set. These next two examples are going to be in standard form. All right, so the better way to maybe do this is to rewrite them in slope-intercept form. So in the space below, I'm going to write out the 1. Y is less than 8. You could also think of this as y is less than a 0x plus 8 if you need to. Either way, some of you will remember that this is the equation of a horizontal line, but if you don't, you can still do slope-intercept. This is my y-intercept at 8. A slope of 0. Okay, if some of you remember, a slope of 0 is a horizontal line. Okay, and then I'm going to look at my inequality because it's a less than that tells me two things. 1, it tells me it's dotted. 2, it tells me to shade below. So we're going to do a dotted line, and we're going to shade below, which is all of this solution, okay, underneath. Now we're going to look at the other inequality, 7x minus y less than or equal to 6. So what I'm going to do is rewrite this in slope-intercept form. You can look back at your notes from last Monday on how to do that. First step is add or subtract this x over. So we're going to subtract it because we want to do the opposite. That's really a negative 1y, so I'm going to go ahead and write that. The x term's always first, then the constant, and then I'm going to divide everything by the number in front of the y. One thing that I need to remember is because I divided by a negative, that's actually going to flip my inequality, and I'm just going to simplify the rest. And I'm going to plot my y-intercept at negative 6, and I'm going to do a slope, and I want it to be a fraction, so I'm going to put it over 1. So I'm going to rise 7, and I'm going to run 1. So I'm going to go up 1, 2, 3, 4, 5, 6, 7 over 1, and I'm going to do that again. 1, 2, 3, 4, 5, 6, 7 over 1. And then I'm going to look at my inequality. It's got a solid line, so I got to draw a solid line, and it's a greater than, so I'm going to shade above. All right, if you're like, I don't know really from this one which one's above, if it's going this way or if it's going that way. So remember, you can always pick a test point and see, like, would 0, 0 be a solution? So if I plugged a 0 in here, or I could even use this one, but let's go ahead and use this one. If I plugged a 0 in there, would 0, and I plug a 0 in there, so that makes that 0, would 0 be greater than a negative number? Yes. So this is the side that we would shade. Okay. Again, the final answer is where the two regions overlap. So they're not overlapping here. That's only blue. But here's where the blue and the purple overlap. So I'm going to just darken that in so that the person can clearly see that that is the main solution set. Okay, let's look at the last example. Okay, so I have 2x plus 3y less than negative 12. And I'm going to put that in standard form. So I'm going to move the x term over. I'm going to put the x term first. And I'm going to divide everything by the number in front of the y. So I'm going to graph y is less than negative 2/3 x minus 4. Okay, this is my y-intercept. And I'm going to do a slope of down 2 and over 3. So down 2 over 1, 2, 3. And I'm going to go ahead and keep doing that pattern. And I'm going to reverse it. Okay, next I'm going to look at my inequality. It's a less than that tells me two things. It tells me it's dotted, and it tells me to shade below. Okay, so we're going to go a dotted line, and we're going to lightly shade below. Okay, let's look at the next inequality. So they have 7x plus 3y greater than or equal to 18. Let's subtract the x term over. Write the x term first. And then divide everything by the number in front of the y. So we're going to graph y is greater than negative 7/3. X plus, that is a 6. Okay, so plot your y-intercept at 6. And then you're going to do a slope of down 7, right 3. And I'm going to do that again. Okay, so they have a common point. That's going to tell me two things. One, that it's dotted. And because it's a greater than, I'm going to shade above. So we've got a dotted. And then we're going to shade above. Okay, so this one might be kind of hard. So remember, for this one we were shading down. This one we were shading above, so down and then above. So the final region is this little itty-bitty triangular space. And that completes our notes for today.